Hey everyone, it's been a while since our last episode. It's good to see you, Aaron.
You too, Ellie. Our episode today can be viewed as an advanced discussion that places Season 1 and Intelligent Cause into the broader context of the other versions of the fine-tuning argument that you may come across. It's from a live recording of our discussion with a group of Reasons to Believe scholars about 3 different ways to formulate the fine-tuning argument. In this discussion, we focused on why it's so important to formulate the fine-tuning argument properly for it to be truly convincing.
Keep in mind that this discussion was more off the cuff than our usual episode, so we might be missing some details here or there. Also, since it was a discussion with scholars who are largely familiar with the fine-tuning argument, Aaron got the upper hand, and the discussion got a bit more complicated than I usually aim for.
It wasn't complicated at all.
Well, I guess our listeners will be the judge of that.
Also, at the end of the episode, we'll add a correction about a point in Season 1, and we'll tell you a bit about Season 2.
With that introduction out of the way, we hope you enjoyed today's episode. I'm Rabbi Dr. Eli Feder.
And I'm Rabbi Aaron Zimmer. And this is Physics to God. In January, I had the great honor and pleasure of meeting Rabbi Eli Feder. He talked to me a little bit about his beliefs about science, and we had some great discussions. He introduced me to his friend and colleague, Rabbi Aaron Zimmer. They have been on our podcast, Clear Thinking, on 2 occasions, and we've had a Zoom meeting with the RTB scholars. And I thought it would be great for them to come on and get to meet our scholar community. And so today they're going to be talking a little bit about fine-tuning, differing perspectives on the fine-tuning area. But it has been a great honor. So our 2 rabbis, they are friends of Reasons to Believe. And I have to tell you, I've listened to a handful of their podcasts, Physics to God. And as everybody knows here, C.S. Lewis is one of my favorite Christian thinkers. C.S. Lewis said that the best communicators are able to take substantive issues, not water it down, but make it accessible. And I have to say, I think Physics to God is one of the best podcasts I've heard. Their approach to science faith issues is very similar to Reasons to Believe. They do a great job. So I want to introduce and welcome Rabbi Eli Feder and Rabbi Aaron Zimmer. It's our pleasure and honor to have you with us today.
Pleasure to be here. We're so happy to be here.
It's good to see you again, Ken, and great to be here and meet everybody. Thank you.
Well, what I'd like you to do is maybe just give a little biography of yourselves. I know that you're modern Orthodox rabbis, but I then would like you to maybe divide up your time and talk a little bit about fine-tuning.
So I guess I'll introduce myself. I'm Eli Feder. Some background, I grew up in, a modern Orthodox home. That means we had a strong commitment to religion, but at the same time, we had a strong commitment to the world and to science. My grandfather was a rabbi and a chemist. My father is a rabbi and a lawyer. And again, my upbringing was very much about the interplay between my religion and my involvement in the outside world. And I never saw it. I never was brought up in a way that there was any conflict or any problem with this. I was always like a math guy. When I was a kid, I was that like math whiz in the class who was annoying and whatever. So that was me. Sure enough, once I went to college, it became natural for me. Again, I wanted to follow in the footsteps of my father and my grandfather of becoming a rabbi. But at the same time, I was very interested in mathematics and I was good at it. So I ended up going for a degree and a PhD in math. Currently, so I'm a professor, I'm a math professor at a community college in New York. And I'm a rabbi. I teach at a yeshiva where that's like post-high school students. And very much, again, Aaron and I have been good friends, and we have a lot of conversations which involve the interplay of our religion, theology, and physics. We started this podcast about 2 years ago or so, but it's based on the culmination of work we've been doing for, let's say, 12 years about the physics, God, fine-tuning.
My name is Aaron Zimmer. I also, modern Orthodox, also grew up. For me, I've always sensed the tension between the modern world and religion in various different ways, culturally, intellectually, due to the conflict between science and the worldview of science and really the worldview of religion, which seemed to me when I was growing up as a teenager, like diametrically opposed in terms of their values. I
When in college, I pursued a physics degree. I didn't go for a PhD in physics or a postgraduate school for a couple of reasons. I wanted to explore many different areas. I'm interested in philosophy and psychology and economics and history. And just when you specialize in one area, you almost limit yourself. It's hard to really practice a general, broad base of knowledge. You kind of are forced to specialize. So I didn't really want to do that. I wanted to find a way to support myself independently working in the world of academia. I ended up trading commodities. I was fortunate to use the ideas of physics, idea of modeling and quantitative analysis in order to study commodity markets and to model them, really based upon, it's hard to describe, patterns, different patterns borrowed from the categories of physics, together with a conceptual approach that I learned from studying Talmud through the Brisker methodology, kind of combining those two to trade commodity markets, oil, gas, cotton, sugar, coffee, corn, a lot of different food, and other items. And I was able to retire, I guess, around 6 years ago. I did it for about 11 years. And, now I study Talmud, I learn, philosophy and science, physics in particular, but just really all areas of science. And Ellie and I have been working on this podcast, Physics to God, for the past year. We've been writing a book we're still working on for the past, 12 years.
Well, excellent. I want to remind our scholar community that they're going to take some questions, so make sure you get them into the chat. Ellie and Aaron, I know that you, like myself, are engaged by this fine-tuning argument, and I think you want to share a little bit about differing perspectives of the fine-tuning of the universe. So I'm going to let you take the discussion.
One thing we came across that I think is not broad public knowledge is that there's different versions of the fine-tuning argument, different ways that it can be presented. And it really matters. It really matters how it's presented. And the different ways of formulating it lend themselves to certain problems. And oftentimes when you see, atheistic scientists attack the fine-tuning argument, they're really attacking one specific form of it.
So this is the most basic short version. Again, we thought there's a balance here, but let's give the basic idea of the fine-tuning argument just to make sure we're all on the same page, and then we'll talk a little bit about different versions of it. So the basic idea are these numbers, quantities in the laws of nature, maybe the mass of an electron or the fine structure constant, which determines the force between two electrons. And these numbers were very, very specific numbers, like 1 over 137.1399137, on a very, very precise numbers. And it was discovered, again, the nutshell of the fine-tuning argument, it was discovered recently over the last, let's say, 40, 50 years or so, that these numbers are fine-tuned, which means if the numbers were a little bit different from what they actually are, fundamental physics would still work out, but it wouldn't result in everything else, all the complexity in our universe, whether it wouldn't be galaxies, it wouldn't be stars, it wouldn't be planets, it wouldn't be life, it wouldn't be atoms and molecules. And it's like our amazing universe is dependent upon these numbers being precisely the way they are, fine-tuned, if you will, and not to be any of the other possible values that they could have been. That's the nutshell of the fine-tuning argument.
He's the one who clarifies, makes things simple. So I'll try to make it a little complicated, and he'll make it simple. Okay, so there's really three approaches. We're going to present three approaches today. One is going to be an argument from elimination. That's the first one. The second one we're going to call the probabilistic formulation. And the third one is the way that we're doing it. We probably should have a good name for it. We'll call the argument based upon the mystery. So the first one is an argument from elimination. This is one I think that it's probably the easiest to present. That's where you basically say, we've seen this in a few different places. I think we've seen William Lane Craig has a video on the internet about it. Basically says, how do you explain fine-tuning? There's a problem. These numbers are precise numbers that are necessary for, usually it's said for life. We'll discuss this at the end, whether it's for life or other things. But saying that these numbers are necessary for life, how do you explain them? The problem of how you explaining fine-tuning. And essentially says there's three possibilities. Either it's necessity, the numbers just have to be that way for some reason or the other, or it's just chance, which ultimately boils down to the multiverse, a theory of an infinite number of universes with different constants and different numbers. And then by chance, one of the universes is going to happen to have the right values, the ones that we see. And of course, we live in the universe which has the right constants because we couldn't exist in any other universe. That would be the second possibility. And the third possibility would be design, some sort of intelligent cause that set the values for the purpose of, often is formulated as bringing about intelligent life. And the argument proceeds to say, well, let's see if we can eliminate two of these possibilities and we'll be left with one. So let's eliminate necessity. There's no logical reason why these numbers have to be that way. I mean, the numbers are, again, 1 over 137. What kind of logical reason is there? These numbers from the framework of physics can be anything. Why should they logically have to be that way? And therefore, it's more or less dismissing the possibility of necessity. And then in terms of multiverse, the second possibility of chance, multiverse is not a good theory for various reasons. One is something called the measure problem. I'm not sure how deep people usually get into it, but ultimately, when you try to turn multiverse into some sort of real concrete theory, it has to maintain that we live in a typical universe with intelligent observers. And we don't. We don't live in, the typical observer would either be just one solar system with a planet, or maybe even just, a disembodied brain, something along those lines. And basically the multiverse is not a good theory. That's not supported by evidence and whatnot. So they eliminate those two possibilities, and then you're left with intelligent design or intelligent fine-tuner as the cause of the constants. That's the first approach, the argument from elimination.
Okay, so maybe I'll pick up the second approach. The first approach from elimination is very easy to say over, and you see the three possibilities. Some like to present it in a little bit of a more rigorous way, which is instead of just saying the first two possibilities, the idea of necessity or the idea of chance are rejected outright, they say, well, it's not quite rejected outright, but instead they try to explain it from, like, I guess, a Bayesian probabilistic standpoint. And they say, let's say we have two rough possibilities that one theory could be the theory of God, an intelligent cause, however you want to say it, theism, and the other possibility could be naturalism. And the question is given these two theories, now we have before us the information that the constants are fine-tuned, and they say, what's the probability, given the theory of an intelligent cause, what's the probability that the constants would be fine-tuned for life and for our complex universe? And on the other hand, given the theory of naturalism, what's the probability that we would get these fine-tuned values? And the idea is to try to weigh these two possibilities, one against another. And the reasoning goes, and again, this is done different ways with different people, given the idea of a God, it seems to be relatively likely or within reason that God would create a universe like our own, a complex universe. But given naturalism, it seems to be very, very improbable that we would get these numbers to be fine-tuned exactly in a small life-permitting range by chance alone. And by comparing these two probabilities, they try to make the argument a little bit more rigorous. This is an approach which is taken in different ways by, like, Luke Barnes is one person, or Robin Collins, and again, there's various ways. And again, it's an attempt to using probabilities of Bayesian analysis to be able to make the argument a little bit more solid than just to say we've outruled necessity and we've outruled chance, and therefore the one possibility left standing is that of a design.
That's the second approach. The key shift is to realize that fine-tuning is not the problem. Okay, when you look at fine-tuning as a problem, you end up with these other approaches. You say fine-tuning is this problem, how do you explain it? There's three possibilities, let's eliminate two of them. Or in the probabilistic approach, fine-tuning is a problem, how can you explain it? Either it's God or it's naturalism. What's the probability if it's God? What's the probability if it's naturalism? But either way, you're starting with fine-tuning being the problem. We think conceptually, it's important to note that fine-tuning is a solution to an intrinsic mystery that exists in physics. Nothing to do with fine-tuning. Richard Feynman has a great quote where he talks about trying to explain the value of the fine structure constant. And he's talking about quantum electrodynamics, which has nothing to do, it's just a quantum formulation of electromagnetism. And he's nothing to do with fine-tuning. It's even before fine-tuning was really discovered, prominent at all. And the question is, scientists are trying to explain the universe. They're trying to explain the world. They're trying to explain all the laws of nature. And they're looking to unify that and to find a simple theory that would explain everything that we see around us. And when they have these beautiful theories, quantum mechanics being, primary example, together with general relativity, part of these theories are these numbers. And these numbers are just these arbitrary from the framework of physics, and we know in 1985 when Richard Feynman wrote this, it's just these like arbitrary numbers, 25 ugly lists of data. And how do you explain that? Scientists are looking for a fundamental basis of all reality. Now, what they've discovered is quantum mechanics, a qualitative set of relationships, plus 25 numbers. And that doesn't sit right with any physicist, as that is the ultimate bedrock of reality, is 25 arbitrary, ugly-looking numbers. And the problem is the mystery, what Feynman calls one of the greatest damn mysteries in physics, is how can you explain a number? What is the approach? What qualitative theory of physics is going to pop out a number like that? And that's just a mystery. It's a problem in physics of how do you explain these crazy numbers? Nothing to do with fine-tuning. And that's an important point. What happened is, over time, scientists started to realize that the numbers were not arbitrary, but that the numbers are fine-tuned, that they have to have their specific value in order to produce galaxies. You need, this is really in 1998, was when everything changed. And for cosmologists and physicists, the discovery of the fine-tuning of the cosmological constant, which is the number that regulates the expansion rate of the universe. And it's fine-tuned to 120 decimal places, which is a fantastically tiny number. If it was too big, the universe expands too quickly, no galaxies form. If it's too small, the universe contracts too quickly. I think I just reversed it. Either way, and no galaxies form. And so the same thing with many of these other numbers that you find out they have to be within certain ranges. What that does is it provides a clue to solving the mystery. The mystery of the constants is, how do you explain these 25 crazy, arbitrary, seemingly senseless numbers? And fine-tuning is a clue which shows you that these numbers are not arbitrary, but the numbers have a purpose. There's a relationship between the value of the numbers and the resultant universe. You can see how if the fine structure constant was different, there would be no atoms and no molecules. If the cosmological constant was different, there would be no galaxies. If the mass electron was different, again, you wouldn't have any atoms. You don't get any details. So you see that fine-tuning is knowledge, is scientific knowledge. The more and more scientific knowledge you have, the more scientists understand about fine-tuning. And that knowledge provides the clue to explaining, answering the mystery, which shows that the cause of the constants is a cause that can set them for a purpose, for the purpose of producing atoms, molecules, life, planets, stars, galaxies. And that shows you that the cause of the constants is intelligent because it operates with a purpose. It knows, so to speak, it knows what is going to result if it makes the fine structure constant not 1 over 137 as opposed to 1 over 139. It understands that, and it set it for a specific purpose, which indicates that the cause is intelligent insofar as it operates with a purpose. It selected a specific value for the purpose of achieving its objective. That's more or less the gist of our approach of showing how fine-tuning is not the problem. Fine-tuning is the clue which points the solution of intelligent cause to resolve the intrinsic fundamental mystery of the constants that exist in physics, independent of fine-tuning.
So given these three approaches, maybe we'll just talk a little bit about, I guess, the strengths or weaknesses, or what questions one might have on the first two approaches and why we think the way we're formulating the argument in physics to God is more robust, if you will, more convincing. And that is, I guess, if we start off with the approach of eliminating the possibilities. And that idea is that the starting off with that there's three possible ways to explain fine-tuning. Again, this way is we start off with the fact of fine-tuning, and how do you explain it? Either it's necessity, that these numbers have to be fine-tuned, or chance, or a designer. And I guess what strikes us as somewhat unconvincing, I think as other people also, is first of all, the argument only works, you need two things. First of all, you have to be convinced that this list is exhaustive, that those are really the only three possibilities. And it's not necessarily clear. In fact, one of the possibilities that have necessity, we think there are really two ways to formulate that, which are very different and have to be dealt with independently. But more generally, it's a symptom of the fact that the whole thing only works assuming the list is complete, and it's not always so clear. Maybe there's other ways. For example, there's at least Mullen has a theory which tries to explain the constants through something called cosmological natural selection. And to say that we've listed all the possibilities, it's not always clear that your list is complete.
Let me just, on that one, the cosmological natural selection, just so you understand that. Ultimately, it doesn't really work, Smolin's theory. But just, you think you have a complete list. It's either it has to be that way, or it's just chance, or some intelligence said it that way. But ultimately, what Smolin did, at least Smolin, a physicist, he did is he tried to use the solution, Darwin's solution for evolution in biology, and apply it to physics. So he has this theory where, inside of black holes, what happens inside a black hole? He speculates maybe a new universe is born inside of a black hole, and each time a new universe is born in a black hole, the constants change. And they change by a little bit, which is where the flaw of this whole theory ends up becoming. He has to have some law to regulate how often it changes, which leads to requirement of meta laws that are fine-tuned. I won't get into what's wrong with it, and then it becomes like some sort of natural selection process where the universes become fine-tuned for producing black holes. Essentially, universes will just naturally evolve over time. You'll have universes which have those black holes. So that's a thing where the constants are changing. They're not necessarily a specific value. They change over time. On the other hand, it's not random chance like multiverse because it's working through this law and this principle that it changes slowly. There's a survival advantage in this cosmological framework. So it's like something in between. And now that's a really creative solution. Just like, nobody really thought about before Darwin, evolution and natural selection. It's something creative, which surprises people. And just once you see that, you say, well, it's kind of not on that list, the list of 3 possibilities. And even if you could disprove Smolin, well, what if maybe there's another possibility that you're missing? So just any time you're arguing from elimination, sometimes arguing from elimination, it's simple, it's clear to give over, it's easy, and there's value in it, but it just always lends itself, there's an element of doubt, or maybe I'm just missing a possibility. And that undermines the entirety of the argument because you're not directly proving to your final possibility, you're just really eliminating the others.
Well said. Another problem with this approach is even assuming your list is complete, the argument from elimination is dependent upon convincingly eliminating the other possibilities. So the idea of chance, you could say chance is unlikely. Well, is it impossible? Is it really eliminated? Or is it just not so likely? Or the idea of necessity. Necessity, it only works if you could really show necessity is impossible. Because if your whole argument is based upon the fact that we got 3 possibilities, we've shown those 2 are impossible, then God has to be true. Well, let's say you haven't shown that they're impossible. Well, they're just there's questions on them. So now you haven't quite fully eliminated them. So even if your list is complete, it only works assuming you rigorously eliminated those possibilities. And it's very hard to absolutely eliminate. Now that I think brings to the second approach and why those who take on the probabilistic approach, I think this is part of what motivates them, is that they see that problem, is that you can't really fully eliminate the possibilities. You can just show it's very unlikely. Given the theory of naturalism, it's very, very unlikely that we would have our constants be fine-tuned by chance alone. Well, then you could compare that to a probabilistic approach. Well, given the theory of an intelligent cause of God, then how likely would it be that we would have our universe? And then they try to compare. Instead of just eliminating the other 2, they try to make a probabilistic comparison. And this is like a Bayesian type of an approach, which is to say, given these 2 theories, what's the probability that we would have our fine-tuned universe? And whichever one is more likely, whichever theory is more fit in line with the data which we observe of fine-tuning, we'll say that's the better theory. And they try to make a probabilistic comparison between these 2 different approaches.
The problem with that approach, it really exists on both sides of the probabilities, trying to really rigorously establish what are the probability of getting the constants given naturalism. That's one problem. The other one is what is the probability of God deciding to fine-tune the universe to be something like our own. Both of those have their difficulties. Let's start with the science one. So is it really that easy to rigorously discover what is the probability that these constants would have their values by chance? It's really not that easy to do because, all you really have is one example of the fine structure constant. We know it's, in our universe, 1 over 137 when something. So what is the probability it became that way? Hard to really figure out. What is the probability the massive electron is so tiny? I don't know. How do you even start quantifying that? So now multiverse scientists have this problem too, because they also try to use probability and chance in order to explain the constants through infinite numbers of universes. So the method that scientists use, and this is, I think, what those who try to present the fine-tuning argument through probabilities also use, it's clever and it's you could argue it, but it has its problems. You try to make an upper and lower bound. So, for example, let's just take the mass of an electron. If you were to say that an electron can't be smaller than, obviously can't be smaller than zero, right? You don't want to have it can't have a negative mass. This doesn't really make any sense. They have a negative energy or negative mass in physics. And it can't be bigger than there's a certain, a Planck mass where basically the particle becomes a black hole. A cylinder particle turns into a black hole. Something along those lines. So you find upper or lower bound. And then what is the probability distribution between those? Is every single value in between the zero and the Planck mass, are they just as likely? How do you know? A lot of times there's a distribution of probabilities where one range of values is more likely than others. But obviously, it's impossible to do. The whole thing is you're speculating about a probabilistic range. So you have to assume a linear distribution. You have to assume that all values are equal in this range. And given that you can successfully try to make up upper and lower bounds and assume that the probability of every value in between is equally likely, then you can calculate the probabilities, and it comes out that the odds are 1 in a trillion, 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 trillion. It becomes incredibly unlikely. That's the most straightforward way to do it. It's the most honest way to try to do it. But it's really speculative. And, people do criticize the approach because they say, look, we've only seen one value. Your whole saying that the odds of these constants are so 1 in 10 to the 120, whatever it is, your whole approach is flawed because you don't really know the probability distribution. And it's a legitimate criticism that this approach has. Can you really rigorously define the probability of every constant?
The other side, they start there and then they say, okay, well, given the theory of God, what's the probability that he would fine-tune our universe? And they say, well, I don't know. What do we really know about God? And they say, well, there's ways to reason that God is good and he's all-powerful and he would want to make a universe like this, or arguments like that. And I think the problem with that type of approach is it's very hard to know what God would do. All we know is that we're talking about there being an intelligent cause of our universe, but to start saying is that we could figure out, or we could reason, or we could say, well, why would God want to do this, or why would God want to do that? We don't really have any way to put probabilities. Even if there is a creator of a universe, how are we to figure out or make a model or some probability function or what the likelihood or probability that he would make a universe like our own? It's kind of just shooting in the dark. We can't tell God what to do. We just see what he did and see what he created and then say, oh, wow, that's amazing. But it's hard to make this probabilistic comparison or a calculation, if you will, to say, given the theory of God, what's the likelihood that he would create a universe that looks like this? There's no real rigorous way to do it. So they did like this type of approach of making like a Bayesian analysis of the different theories. Given these probabilities, it's like there's a lot of hand waving going on, if you will, is to try to assess taking things which are not really subject to a solid, probabilistic computations, and to try to somehow put numbers. Obviously, there's not numbers, but try to assess the likelihood of these different theories. It just doesn't quite compel a person to really be convinced that this is really a better theory because it's more likely that God would create it as opposed to make fine tuning as opposed to the naturalism.
Right. Very often this probabilistic approach, which is the more rigorous version that's presented popularly, is criticized by scientists and is very often on this angle of what would God do? Like we saw Sean Carroll really go after this approach, and almost all his questions are always based upon, well, if I were God, I wouldn't make a universe like this, and how do you really know that? And it brings down the fine-tuning argument. It drags it into the mud. It really forces it to like deal with problems that it shouldn't have to. For example, if you and it's legitimate questions when you formulate it this way, is you end up with the problem of evil. Now the problem of evil all of a sudden rears its ugly head. And, Sean Carroll was saying, well, why would a God who's all good make children who, have diseases and birth defects and natural disasters? And I'm sure you guys are familiar with all the problems that people raise against it. And if you have to be honest, is if your argument is, if given God, what is the probability he would make a universe like our own? Well, now you've created that problem for yourself by formulating the fine-tuning argument from an attempt to psychologize God and to figure out what God would do. Now you have to say, well, given God, what are the odds of him making a universe like our own? Well, then Sean Carroll's a good question. I mean, if God is all good and all powerful, why do you make a universe where anything but evil ever happens? And then you have to say, well, because of free will or whatever people want to say to answer these types of problems. It's just really an unnecessary baggage to start bringing the problem of evil into the fine-tuning argument. That just doesn't belong. It's not necessary. And you give physicists like Sean Carroll, they give them the high ground. You let them think they've disproven the fine-tuning argument because of, an earthquake. It's a relic of the fact that you're formulating the fine-tuning argument through this attempt to give a probability that given God, he would make a universe like our own, which is, again, we don't think is necessary.
So basically our approach is you'll explain a little bit now why we think the way we're approaching it avoids these problems. And the idea is that we're really starting off with the mystery. This is a mystery which has nothing to do with God. It has nothing to do, it's just a physics mystery. Richard Feynman, who's not discussing theism or atheism or anything, he's just trying to figure out physics. And it starts with this mystery about how do you explain the values of these constants. And good science leads to the conclusion, leads to the discovery of fine-tuning. Fine-tuning is the clue which helps us. The numbers are not just these random numbers as Feynman and others thought. They're not just, they could have been any old numbers and they happen to be these numbers. No, these numbers are precisely the numbers which are necessary to bring about our complex universe. And that discovery is the clue which points us, how do we understand these constants? And since the values are those values which are perfect to bring about the goal of our complex universe, that indicates a certain type of a cause. It's a cause which is like a teleological cause, a cause which the numbers are this way for the purpose of bringing about our complex universe in the future. And once we recognize that this is the way to explain, the fine-tuning shows us the way to explain the values of these constants, that leads us towards an intelligent cause. Because an intelligence is the type of a cause, and it was an intelligent actor acts with purpose. And there's an objective. An intelligent cause acts with the purpose of bringing about a certain result. And because of the fact that we see the correlation between these values and the end result, it points to the fact, it indicates that the cause of these values is intelligence, not just some blind force which doesn't know what it's doing, but it points to the fact that it's a type of a cause which sees the end result of what it's bringing about and chooses those numbers which are precise to bring about that end goal. And that's kind of the idea that follows from the idea of the definition of intelligence. And intelligence is like a measure where a person of intelligence selects one possibility from the set of other possibilities for the purpose of bringing about some intended goal. And therefore, when we follow the clue of fine-tuning, it directly leads towards it indicates the idea that they're created by an intelligent cause. Right. So the point is, it's not starting with a problem and ruling out other possibilities. On the contrary, it's starting with a mystery and following the evidence and showing where it leads to. So it indicates, the idea is that fine-tuning indicates an intelligent cause. And while it's true there might be other possibilities which one has to take up, and like multiverse is another possibility, but since the argument directly points to an intelligent cause, the burden of proof isn't on us to outrule the other possibilities. The burden of proof is on an atheistic scientist to be able to present another cogent theory which explains that this is all an illusion, that fine-tuning is an illusion. It doesn't truly indicate an intelligent cause, but it could be explained by a non-intelligent cause. And we go through that in a rigorous way to show why multiverse fails to do so. But we think that by starting with the mystery and the solution of how fine-tuning points in this direction, it changes the burden of proof to those who are trying to undermine the argument of an intelligent cause.
Right. So we explain a weakness of our approach, what's the weakness that it has, and then a general strength that it has, besides the weakness of the other approaches, a general strength. So let's start with the weakness first. The weakness really lies in this concept of indication. It's the idea that the evidence points to the simplest, straightforward interpretation. So we're arguing that there's an idea of an indication. If you have, or example that we use in our podcast, I forgot, it's episode 10, we talk about the idea when you find a murder weapon, which has the fingerprints on the person, the suspect is at the scene of a crime. So the evidence points and indicates that, the suspect did it. Now, are there other possibilities? Maybe there's a conspiracy going on. It's true. And it's possible there's such a thing as conspiracies. They could happen. There just could be the illusion that this suspect, John, did it, but he might have been that somebody else did it. So that's true. We agree to possibility of other theories, but there is that first, it's a type of Occam's razor in methodology, that when evidence indicates something, that becomes your first theory. That's the simplest assumption. That's what your mind goes to. And there is a reality to the way the human mind works, that when the evidence all lines up and points to something, it indicates that, and that becomes, there's a certain primacy of that explanation. Again, it doesn't prove the other theories are false, but it creates, like Ellie was saying, it creates a burden of proof. If you want to posit there's a conspiracy, there's something else that's creating the illusion that John murdered him, the burden of proof is on, the defense to support that by actual evidence. Likewise over here, the evidence indicates when you have all these numbers lined up exactly that in order for it to get a universe with atoms and molecules and stars, that indicates that the cause was intelligent. If scientists want to maintain that it's really just an illusion of fine-tuning, and there's in a certain sense a natural conspiracy because there's an infinite number of other universes that nobody's ever seen where the constants are all different and there's no atoms and there's no molecules, there's no stars in these other universes. And it happens to be one universe, you have stars, and you have atoms, and you have life and all these things. And it just looks like that to us, where we're under the illusion that the universe is fine-tuned. And there's essentially a big cosmic conspiracy, according to them. It's possible. They have to provide justification that there's an infinite number of universes, that the constants really do change, and that the typical universe that has intelligent observers is something like our own. And they can't just speculate that maybe there's an infinite number of universes, and maybe the constants change, and maybe the typical universe is our own. They have to actually provide justification for that. And when they try to do that, they end up having problems. They end up having problems when they try to justify it and establish multiverse with real justification. But it's important to see where the burden of proof is. Again, the weakness of our own is that you have to buy this idea that the human mind follows a type of Occam's razor when it analyzes evidence and it sees that there's a simple, direct explanation, which becomes the primary one, unless you could really show that the other explanations have some sort of support and justification to make you question that.
The strength is that the way the other presentations start is they start out with fine-tuning and they say, here's fine-tuning, how do you explain it? Well, there's 3 possibilities, let's eliminate the other 2. Or here's fine-tuning, and let's try to weigh the different probabilities given these 2 theories, which one is more likely to explain fine-tuning. And one might say you're just picking off one thing in our universe, which we don't understand. And you might say that sometimes people raise it, that's God of the gaps type of a problem. That's just one thing in our universe that we happen to not understand. Maybe that's just something which we will understand as time goes on. But the way we present the argument, we show how this is not just picking out some detail like the eye, how do you explain it? But this is a problem which emerges from fundamental physics. This is at the core of physics, is trying to find the unified theory of everything. And trying to explain, as Feynman said, this is one of the greatest damn mysteries of physics. How do you explain these constants? It's not just a gap in our knowledge, it's getting to the core of our universe. How do we explain the basics of our universe? And when we follow the clues naturally about explaining these constants, we've discovered that they're fine-tuned. And that leads us directly towards the fact that they have a teleological cause, which is a result of an intelligent actor. When we realize we contextualize fine-tuning as the solution to a problem that lies at the heart of the foundations of our universe, it's clear that it's not just a gap in our knowledge that we're filling with God. Rather, it's what naturally emerges from the most fundamental of scientific analyses.
Right. And it's clear also that fine-tuning is not, it's not argument from ignorance. If you formulate it as there's a problem with fine-tuning, how do you explain fine-tuning? It just sounds like science doesn't know how to explain fine-tuning. And then religious people come in, oh, God did it. But when you formulate it this way, fine-tuning is not the problem that we're ignorant about the solution. The mystery of the constants is the problem that scientists don't know how to solve. Fine, wait and see if you have an explanation. They waited decades and they have an explanation. They discovered fine-tuning. Fine-tuning is knowledge. It's scientific knowledge about the constants, how if you change them, there's no atoms. That's knowledge. That knowledge is the solution to a mystery. So the argument of fine-tuning isn't coming from ignorance. It's coming from knowledge to explain a mystery that you're ignorant about. That's not God of the gaps. That's just called good scientific-based philosophy. There's one other point we want to make, a general broad point that we do differently than everybody else. It's generic and something inherent about the other approaches that they don't do this, they just don't. But very often, both multiverse scientists and religious people present it as fine-tuning for life, fine-tuning for intelligent life. And multiverse scientists in particular have to do that because their whole approach is to say there's an infinite number of universes. Why are we in the one universe which has all these constants? Because there's no intelligent observers in any other universes. And it's a historical irony that scientists are now forced to formulate that the laws of physics that we observe are a consequence of the anthropic principle. It becomes centered around human beings in a certain sense, around an observer bias. Not because there's any direct purpose, of course, in the framework of atheistic scientists, but in a sense, the observer bias of intelligent observers constrains the laws of nature that we can observe. And religious people want to say that there's fine-tuning for intelligent life because religious people are trying to get divine providence out of this argument. The problem is the fine-tuning is really for, when you look at it, it's really for atoms and molecules and stars and galaxies and everything in the universe. And there's a wonderful, complex universe in all its grandeur, which has many different types of things, not just intelligent life. And from the fine-tuning argument itself, all you really can show is that there's an intelligent cause that set up the laws of physics and the constants of nature in order to produce a ordered, structured universe with molecules and atoms and planets and life and stars and galaxies and everything in the universe. And there's no real evidence from fine-tuning itself that intelligent life in particular was fine-tuned for. Maybe you can argue this since there's some fine-tuning that has to do with carbon. Maybe you could argue that if carbon is only necessary for life, it's not necessary for anything else. So maybe you could say there's a specific purpose of life. I don't know. But in general, it's not really, it's fairly weak, the evidence. But the fine-tuning argument is a very strong argument for God, for an intelligent cause of the universe. And when you try to get too much out of the argument, you kind of lose it. There's a Talmudic saying, if you try to grab too much, you grab nothing at all. You have to sometimes, what does the argument give you? And it gives you the strongest argument, in our opinion, in the modern world for an intelligent cause, for God who created the universe, for a purpose, an intelligent agent. That's pretty good. That's pretty good in the modern world if you can really do that and establish that. The reality is that if you want to prove divine providence, you have to make recourse to other arguments. We're just not discussing those things. And I think it's a mistake to try to get everything out of this one argument. You end up exposing yourself again to a physicist saying, well, how do you know that everything is made for life? How do you know, maybe everything is made for, human lice, everything, if without all these things, there's no such thing as human lice. They wouldn't exist. Maybe they are the whole purpose of everything. You end up exposing yourself to all these problems. And then people think, that's a good question. The fine-tuning argument isn't that good. So we think it's important to formulate it properly, the way we, from the mystery to the clue to the idea of an intelligent designer. And it's important to not try to get too much out of it. Be happy if you can really rigorously establish in a clear, compelling way to a person that the cause of the universe is intelligent and there's something, beyond that, set the constants for the purpose of getting a complex universe. We think that's what the argument really shows in a compelling way, and it's important to formulate it without trying to get too much.
One last thing before we move on is that this conversation we've had today, again, we're with a group of scholars, so perhaps we got a little more complex, and maybe depending on everyone's background, I know different people might have different backgrounds and different familiarity with fine-tuning argument, and I just don't want to give the impression that our podcast is as rigorous and technical as we've been talking. So it's my job on the podcast to try to, we have a give and take.
Yeah, you haven't really done that today.
I haven't done that so much. I haven't been cutting them off. But in the podcast, if you listen to it, I'm a math professor in a community college, and my students don't get it. And they've tried to learn math many times, and I'm teaching them things which they've never understood. And it's kind of my job to try to break things down simply to get into the mind of the student. And again, I kind of let Aaron go a little bit and let him get a little more rigorous and complex, because again, we think that our argument on the one hand is very accessible. We do a lot of work to try to break everything down simply. The podcast does not sound like we sounded today. But at the same time, we also think we're adding like some rigor to the argument in a way which is not necessarily found in other presentations. And therefore, I think we wanted to get that across. But if you didn't fully get all the details of it, that's okay. And, if you want to hear, we'd recommend you checking out the podcast Visit to God, or would love to have any follow-up questions. Anyone could email us. We'd love to have this conversation in a more, again, I apologize if we got a little bit more rigorous than was necessary, but at the same time,
that's great. I don't think you should be wrong. I think it was fine. Everybody loves complexity.
Yeah. So that's, that's where we differ sometimes, and,
Well, very good. Ellie and Aaron, thanks so much for that presentation.
Hey everybody, we hope you enjoyed our discussion. Before we sign off, we want to make one additional point. Because Feynman's mystery of the constants plays such an important role in our formulation of the fine-tuning argument, we want to correct one aspect of how we presented it in prior episodes. The correction involves the possibility of a future qualitative theory explaining the exact values of the constants.
We want to emphasize at the outset that this point doesn't impact the essence of the fine-tuning argument, but only demands that we understand the mystery of the constants in a deeper light than we originally presented it.
Before we even got to fine-tuning, we explained why the values of the constants presented such a great mystery. One aspect of the mystery is that 25 arbitrary numbers read like a list of data and are the exact opposite of what physicists are looking for in a dreamed-of final theory. That hasn't changed.
The other side of the mystery is that it seems highly improbable that any qualitative theory would produce a number like the fine structure constant, 1 over 137.035999, or any other of the constants of nature for that matter. The way we said it was that a theory of everything had to perfectly determine the exact value of all the constants down to the last decimal place, which is a very tall order. In a sense, we overstated the case. There was arguably never any hope that a theory of everything would be able to directly determine all the numbers down to the last decimal place.
The reason we explained it like we did is because that is how Feynman presented the mystery in his 1985 book, QED. However, physicist Carl Rosenzweig filled us in on some details of the historical background that are relevant to the mystery of the constants. You see, in Feynman's presentation of the mystery, he implicitly dismissed a different approach that physicists were working on during the late 1970s and 1980s, around the same time that Feynman discussed the mystery of the constants. While the point is a bit technical, Aaron, maybe you can try to explain it as simply as possible.
Sure, Ellie. Physicists were pursuing grand unified theories, different from theories of everything because grand unified theories don't include gravity. Now, one of the major motivations for grand unified theories was the hope that at higher energies, when the universe was hotter and denser in the past, it would be shown that the three force constants are unified into one constant. Then, over time, as the universe expanded and cooled, the effective values of the different constants separated and functionally expressed themselves as different values. If this were so, the hope was that the true unified value of this one constant would be something simple like 2 or pi. If that were the case, physicists could hope that they would be able to find some qualitative explanation for it instead of something as random as 1 over 137.035999.
I know you're trying to be simple, Aaron. Let me try to summarize the point in a bit of a simpler manner. Before the discovery of fine-tuning, some physicists held firm to the possibility of finding a qualitative theory of everything that would explain all the values of the constants. They had hoped to discover some qualitative theory, whether a grand unified theory or some other theory that would produce a simple number like 2 or pi, that through some complex physical process would end up expressing itself as the three different force constants that scientists actually measure, one of them being 1 over 137.035999.
Physicists wouldn't necessarily have to calculate precisely how to get from the true simple number to 1 over 137, but they hoped to at least show the path to making the calculation, even if it was very complex.
Even though this was the scientific background of popular theories in the mid-1980s, when Feynman discussed the mystery of the constants, he didn't explicitly mention this approach. It stands to reason that he viewed this attempt as implausible to work for all, or even some, of the constants.
While it's hard to know exactly why Feynman rejected it, perhaps it was because the method of grand unified theories at best only potentially worked for 3 of the 25 constants. Or maybe he thought the entire approach of deriving all the values of the constants exclusively using qualities seemed very difficult to work out. Again, this doesn't mean he considered it impossible, only that from the perspective of modern physics, it was a great mystery to try to explain these numbers even before the discovery of fine-tuning.
As it so happened, Feynman's formulation of the mystery of the constants has proven robust. Grand unified theories and their attempted solution to even part of the mystery eventually fell out of favor. This is because it became clear over time, as calculations became more precise, that the values of the three constants don't unify at higher energies, but actually diverge from each other.
That, among other reasons, such as grand unified theories making incorrect predictions like proton decay, eventually led to grand unified theories falling out of favor entirely. And 40 years later, there's still been no progress in explaining the constants using this type of approach. Meaning to say that try as they might, physicists have been unable to find qualitative principles that would predict simple numbers which ultimately become the precise values that we measure.
Again, we want to emphasize that this whole discussion involves the plausibility of a qualitative theory explaining the constants, assuming that they're arbitrary random numbers with no rhyme or reason. However, once scientists discovered in the late 20th century that the constants are fine-tuned, this entire approach doesn't work at all.
This is because even if the hope and dream were realized, in other words, even if some qualitative argument gave the number 2 or pi, which through a series of calculations happened to become 1 over 137, it would still be an immense coincidence that those values are exactly within the range of values necessary for atoms, molecules, planets, life, stars, and galaxies.
As we explained at length in episodes 3 through 5, with the discovery of fine-tuning, there remain only 2 possible theories that could account for the apparent relationship between the specific values and the emergent complex universe. Either an intelligent agent that intentionally selected these values for the purpose of producing our complex universe, or an unintelligent multiverse that explains away the apparent fine-tuning as an illusion, as a mere result of an observer bias.
We'll have much more to say about the multiverse in Season 2 coming later this year, which we'll call Understanding and Rejecting the Multiverse. Even though a theory of infinitely many parallel universes may sound wild and crazy, given that many scientists embrace multiverse these days, we think it's important to take it very seriously. To do so, we're going to break the multiverse down into its basic premises, assess its various supports, and see what's really wrong with it.
We've done most of the hard work and are almost ready to start recording. We hope to release about a dozen episodes later this year. There's going to be some fascinating new science to learn, and I've fought with Aaron tooth and nail to keep things simple.
Well, what he really means is he took out all the best parts, but okay.
No, I mean that we took out all the parts that were too complicated for no reason. Anyways, it's going to be very clear and easy to understand. In the end, you'll understand clearly why the multiverse isn't a good scientific theory, but is rather a bad philosophical theory.
On a different note, we wrote a summary of our 3 main arguments from Season 1 in an article called 3 Proofs of God from Science. You can find it on our website, physicstogod.com, under Resources. We link to it in the show notes.
In the meantime, subscribe to Physics to God at Apple Podcasts, Spotify, or wherever you listen to podcasts, so you'll know when we begin Season 2.
I'm Rabbi Aaron Zimmer.
And I'm Rabbi Dr. Eli Feder, and this is Physics to God.